Alright, problem number 5. An ant is climbing up this cylindrical can with a path that has a slope of 45 degrees, as shown here. Okay, and the path that he follows is called a helix. If the can is 6 inches tall, let's mark that on here, 6 inches tall, how far did the ant walk? Okay. Well, you might be tempted to think that, that we don't have enough information because we don't know what the diameter of this can is. But let's work with what we know. And with this, what I want to do is I want to slice this can open and lay it flat. Okay, so we're taking the surface area on this surface, not the top and the bottom, but the sides. I want to slice this can open, and I'm going to slice it right at the point where the ant starts to walk up the can. Okay, so let's slice it and lay it out flat. So when you take the cylinder and lay it out flat, what's it going to look like? It's going to look like a rectangle. Okay, and the rectangle will look something like this. If I can draw a decent rectangle. And okay, so this is where we've sliced it, and this is where the ant is walking up the can. Okay, all right, so this edge here is the same as this edge over here. Okay, and the height of this rectangle is 6 inches, just the same as the height of the can, and the length of the rectangle is going to be the circumference of the can. Okay, so let's first of all take the case where the circumference is greater than or equal to 6 inches. Okay, because that's a little bit easier to see. But if the circumference is greater than 6 inches, then the ant is going to walk up at a 45-degree angle. Try and draw this at a decently 45-degree angle. I don't know if that's... and if it's a 45-degree angle, then we have a 45, this is a 90-degree angle here, this is 45 degrees, this is 45 degrees down here as well, and we could actually drop a little perpendicular here. So this will be a square, right? That makes sense because it's an isosceles right triangle. So this is going to be 45 degrees, this is 45 degrees, and if it's an isosceles right triangle, then this length here up to this point is also going to be 6 inches. Okay? And then you can see that the path that the ant is walking is just this diagonal across the square. And you can use the Pythagorean theorem and say that 6 squared plus 6 squared is equal to the diagonal squared. We'll just call it c squared. Alright, so 36 and 36 is 72. Alright, and that's c squared. And if we take the square root of both sides, we get square root of 72. And you could is equal to c, and you can see that this is 36 times 2, so we actually get, we can pull the 6 out, alright, because there's a 6 squared under the radical, so we can take a 6 out, and then so we get 6 times the square root of 2 is equal to c. Okay, and 6 times the square root of 2 is about 8.5 inches. Okay, so that is the answer. But you might be thinking, well, what if the circumference is less than 6 inches? Well, let's draw what that looks like too, and see what's going to happen in that case. So I'm going to draw a narrow can and slice it open. Okay, so if we had a narrow cylindrical can, and we sliced it open, And the circumference in this case is less than 6 inches. Okay, so I'm going to write that up here, circumference. Circumference is less than 6 inches. Okay, so this would be an awfully narrow can, but just to make a point, we'll make it nice and narrow like this. So again, we have the ant walking up at a 45-degree angle. And when he gets to the edge of the can, this isn't really the edge of the can. This edge meets this edge, okay? And so what's going to happen is he's going to emerge over here. All right, let's get perpendicular over here. So he's going to actually emerge over here, and it happens this one kind of looks like is ending up to be twice the but it doesn't really matter, I guess. So what happens is he ends up going, in this case it kind of looks like he's going to go around the can twice. Alright, so but you can see that his path, if we were to take this top part of the can and shift it over, okay, so that these paths meet up, you can still see we have a 45 degree triangle, and the path is still going to be 6 times the square root of 2 in length. Okay, so all I've done is take this and shift it over to here. Okay, just cut it and shift it over. Okay, but the path length is the same. If we have 6 inches here, then this is going to be 6 inches here if this is a 45-degree angle. Okay? Does that make sense? So either way, it's still 6 times the square root of 2, which is interesting because it doesn't depend on the circumference of the can. The ant is going to get to the top of the can with the same path length regardless of what the circumference of the can is. So that's kind of interesting. And the answer, let me just repeat that, is 6 times the square root of 2 inches, or approximately 8.5 inches. Alright? So there's your answer. There you go.